So yeah, hi, welcome back once again. Today we are going to solve this problem called median of two sorted arrays. So yeah, let's go into this question. Given two sorted arrays nums1 and nums2 of size m and n respectively, return the median of the two sorted arrays. The overall runtime complexity should be O of log m plus n. So uh, it's very much clear, like it's stated that we need to use log of m plus n time complexity. So it's pretty much assured that we need to use binary search probably. So let's see like how we will move further. So let's have an example like nums of 1 is equal to 1 comma 3 and 2. So obviously, yeah, the median will be 2. Okay, now moving forward like 1 comma 2 comma 3 comma 4. So median will be 2 and 3, and 2 plus 3 divided by 2 will give us 2.5. So here, like what all is our observation? Let's please take it down. So observation 1. So first one is we need to use binary search. That's pretty very much clear. Second observation was like if the size, if the sum, if the sum of the size is odd, so odd, we will need one element. If the sum of the size is even, we will need two elements, two middle elements. So yeah, I think that is what we know about this thing currently. So now we need to probably think like how we can modify our binary search to make this thing work out. So mm, one way is to like have a mn element and mx element, and probably like iterate between those mn and mx, and to find like how many elements in this array are less than those that given m element. Like what I was thinking was like either the range will be like from 1 or the starting point of nums2, like either minimum number will be 1 or 1 comma 3, like out of first element from nums1 and nums2, or either the largest element will be like 2 comma 4, like one of those things. So what I'm trying to say is that minimum element will be either nums1 of 0 or nums2 of 0, and max element will be either nums1 of n minus 1 and nums2 of n minus 1. So we will get a range like the elements which will be in, like we will get a range like the median will be in between these two numbers. That's very much clear. And what we can do is like we can get a count of element, like let's say this is my lowest point and this is my highest point. So if I get a mid at some L plus h minus L by 2 point. So what all are the numbers which are lesser than that in nums1, and what all are the numbers lesser than that in nums2? If that number, if the count of the number which we will get, if we will get the count of the numbers, and we will see like are, is it like n by 2, are the n by 2 numbers lesser than that element or not in that array. So that is like what I am thinking of currently. So let's try to solve it by that way, and let's see like if that works out or not. So yeah, let's get started. So I will be taking int n1 as okay. First we will get int l. L will be probably, so yeah. It's mentioned here that mm, okay. So it's clearly mentioned here that sizes can be zero also. Like nums1 can be 0 and nums2 can be 0. So Okay, so we can have like if nums1 dot size is equal to 0, uh, so we will have like int l here, and similarly we will have int h here. So we will get like nums1 of l is equal to nums1 of 0. Okay, uh, like nums2 of 0, because as nums1 dot size is 0 here, and at the same time h will be equal to nums2 of nums2 dot size minus 1. So yeah, this is very much obvious what I have written, and there will be else if condition. Let's have like nums2 dot size is equal to 0. So L will be here nums1 of 0, and H will be equal to nums1 of nums1 dot size minus 1. Or else condition will be L is equal to nums mean of, let's say both of the sizes are greater than 0. So in that case we will have to get a mean element. So yeah, so L is equal to mean of nums1 of 0 comma nums2 of 0, and similarly H is equal to max of nums1 of nums1 dot size minus 1 comma nums2 of nums dot size minus 1. So we got like what is the range in which we need to find that number for. So now let's start solving it. uh, okay, yeah, so let's define here int n is equal to, we could have got like, okay, we can replace it directly there. Okay, int n is equal to nums1 dot size. So yeah, so and m is equal to nums2 dot size. So if n is equal to 0, so yeah, and if nums1 here, I actually wrote wrong. Yeah, nums2 is m, right? Yeah, and here it is m is equal to 0, and here it is nums of uh, n minus 1. Yeah, and here it is like n minus 1, yeah, n minus 1 and m minus 1, nums2 of m minus 1. So we got like so yeah, here we got like the low and high here, and now let's start solving while L is less than equal to H. So while L is less than equal to H, so now we need to see like how many elements are less than that element, right? So we need to go on expanding the number until we hit that number. So like what I'm trying to say is like there could be a possibility that nums1 might have 1 comma 7 6, and here they might have like 8 comma 20. Let's take it as, okay, let's take 20. So what might happen is like, let's say 1 comma 10 comes. Okay, so if 10 comes, then there are two numbers less than two numbers, one number less here, and one number here, no number is here lesser than 10, so 0. So 10 could also work as a median here, but we need to hit properly a 6. Or if we don't hit properly a 6, then the number which we are trying to find it as a median will not be there. So basically what I'm trying to say is that, let's say like 1 comma 6 is there and 20 is there. My mid comes out to be my mid will start from this 21 slash 2 will give me a 10. So 10 will be something like here, somewhere here. Okay, means it's not there. Let's imagine like 10 is the bigger number than 1 comma 6. So what will happen, like it will be acting as a median, like there are two numbers lesser than that and one number probably greater than that, uh, one number here. So it will act as a median, but it's not properly a median. So we need to be sure like whether we need to go back or we need to go front. So yeah, that's my point here. Okay, let's solve it. You will get a clarity. Int m is equal to l plus h minus l slash 2. So we got like the number like here, like what is the midpoint, and let's get count. Okay, int count is equal to get count uh, so get count and so okay. mm, okay, yeah, so get count and we will have like here nums 1 as passed here, nums 1, and we will get m here. Okay, plus equal to get count nums 2 comma m. Okay, so now what does the get count function will do? It will find the number lesser than the uh, m. So int get count, here we are passing vector int nums. Let's have int n is equal to nums dot size for int I is equal to 0, I is less than n, I plus plus. Okay, so okay, one more observation for me here was that since there are three number, there should be two number greater than that. So we will have to do 3 plus 1 slash 2. Like we will need to take plus 1 here. Means what I'm trying to say that we will be taking the ceiling one, not the floor one, while performing the division operation. So that is also one thing which I observed, so that I can be sure that there is one element, two elements needed to be there. Okay, median will be at index 1. Okay, okay. Yeah, let's see. So if nums of I is less than m, we will have int count is equal to 0 and we will do count plus equal to 1. Okay, and we will have return count. So that's the point what we are trying to do here. So I don't think so. One way I'm thinking like we can optimize this is like we are having a many random very random numbers also, that's pretty sure. So one thing is there that we don't want those random numbers to be there, like what will happen is like 1 to 3 is there, I have will that will be in the range of 1 to 3. So here it will work out. Let's take our example only, 1 6 20. So here what will happen, m will get as a 10. So we will get as a 10. Okay, so since m is equal to 10, we will send it here. Okay, so we will get two numbers on the left side here, and we will get here 20. So for a number to be a median, it needs to have like one number on the left and one number on the right. That means the number itself should be there. So which 10 does not make that sense, right? Like here count will come out as 2. Okay, so that means we need to reduce the, we need to perform h is equal to m minus 1. Okay, yeah, so that I think should make a sense. So let's have that written down. If count is greater than, okay, so since what should be the count, desired count, int desired count, desired count, so it should be like n plus m. Okay, so what I'm trying to do here is like uh, okay, first let's have like if n plus m. Okay, so what? Okay, wait, let me do one more thing. So if there are three numbers, okay, one, two, three, three numbers are there. So if I put it down in a sorted fashion, 1, comma 6, comma 20. So three numbers are there. 0, 1, 2, they are numbered. N plus m will give me 3. 3 slash 2 will give me 1.5, which will make it as 1. So so yeah, that's actually correct only. So we will have like one number should be there on the left, and that is what we want here, to be very honest. And what if the number is odd? 1 comma 6 comma 20 comma 40. Here we will need both of these numbers. So we will have like 4 slash 2, which will give me 1. So one number we will get as 6. Okay, and that's perfect. Like we want actually one number to be on the left side. So this is working out pretty cool. Let's try one more example. 1 comma 6 comma 20 comma 40 comma 50 comma 60. So in this case, I think these two numbers should be there. So what will happen? 6 slash 3 we will get. 6 slash 6 slash 2, which will give me 3. So okay, we are getting somewhere stuck here. Mm, so so my thought process is actually correct, but I need to just you need to pay it. So 1 comma 6 comma 20 comma 40 comma 50 comma 60. So we got like 6 numbers here. So n plus m will give me 6. Okay, and we are trying to get the middle element. So that's the middle element for us. So I think we will need to have like different ways here, like okay, okay, let's have 3 here. 0, 1, 2, 3. So 4 slash 2 is 2. Okay, here we did wrong. 4 slash 2 is 2. 0, 1, 2. Okay, so okay, so to get that element I need to perform 6 minus 1 slash 2. Okay, so yeah, that's good what we are doing. So count, if count is greater than uh, desired count. Okay, so desired count is n plus m slash 2 simply. So let's confirm it for the odd number once again. 1 6 23, 3 slash 2 is 1.5, which will make it 5. Okay, perfect. So if count is less than desired count, if count is greater than desired count, we need to perform h is equal to m minus 1. Perfect. So how this will help is like it will move our h to m minus 1. So now what will happen is like let's dry run for this 1 comma 6 comma 20, 1 comma 6 comma 20, 1 comma 6 and 20. Okay, let's we have actually merged it only. So 20. So first I will get m is equal to 10. So for m is equal to 10 count I will get is 2 on the left side, which is greater than the desired count. H will be equal to m minus 1 9. Now it will be 0 plus 9 by 2 4.5. 4.5 will give me 1. Okay, okay, now let's like if 5 is there as a m, so what will happen? If 5 is there as a m, then we will get 1 less count. So that is actually desired. Okay, so that will okay, so that is desired. Okay, and okay, fair enough. Now we will do else answer is equal to m, pretty simple, and L is equal to m plus 1. So what I did was like, uh, we got L as m is h is 9. Now m will turn out to be 4.5. M is equal to 4.5. Now what will happen, like here it will go, and here it will, to perform answer is equal to m. So answer will become like 4, and L will be equal to m plus 1, which will be 5. So now what will happen is like 5 plus 9 by 2 it will happen, which will give us 7. So at 7, what will happen? It will not work out. H will come to 6. Similarly, L will come to 6, and they will like probably get stuck up here. So we will get answer at 6 here basically. So if you want, I can print it once. Like we can have it printed there. So yeah, I will print it for you 1 minute. So let me comment this out, and let's have it printed here. Uh, See out answer, and let's return 1.0. And let's have int answer here defined. So let's get that printed. See out answer. So yeah, let's see. So okay, we will see for that again. So let's have our test case here. 1 comma 6, 1 comma 6 comma 20. Run. So here you can see we are getting the correct output only. So yeah, for this also I think we should get 6. So yeah, it's working fine for the odd numbers, odd length. Now we need to figure it for the even length. So what will happen in an even length which will be different is like we need to reduce desired count by 1 basically. So if you see, like we are always having at the end, right, like the right part we are getting it. Like if you will see here, like the length is 6, and when we are doing 6/2, so we are getting 3. Third position 40 is there, but we need to include 20 also, which is desired position minus 1. So we need to perform that thing. Okay, so yeah, so if n plus m, also we need to write here condition if n is equal to 0, and then m is equal to 0, we need to return 0, 0, something like that. So if n plus m mod 2, so we need to return an answer. Okay, so now performing it for the other part. Okay, so yeah, int num2, let's have it as num2. So again, like desired count minus 1, desired count minus equal to 1. Now performing the same operation here, defining L is equal to same thing like okay, I think we need to define it as int left small high max h max left L min, and so L min will be equal to this, and h max will be equal to this. Similarly, L min will be equal to this, and h max will be equal to this, and L min will be equal to this, and h max will be equal to this. So, and then before this, int L is equal to L min, and int h is equal to h max. Now coming down again here, we need to define it here. Okay, so this one is pretty big question, I think, or am I making it some? I don't know. So yeah, we got L is equal to L min, H is equal to H max, and we figured like we again perform the same operation, desired count. Just here the number will be num2, num2, and we will return double of double of HL, sorry, answer plus double of num2 slash 2.000. Try this thing out. Heck, there will be some errors, I think. Okay. So yeah, this one got accepted at the first time only. That's pretty cool. So I think you guys were able to understand what I was basically trying to do here. So yeah, this was my approach to this question. So yeah, we basically did like two times binary search, so which makes it like k log n, and like we get it for like log n only, basically log of n plus m. So yeah, that was basically my approach. Yeah, thanks everyone.